Muy buenas, mi nombre es Álvaro Sancho y hoy, junto con mi compañero Andrés, os vamos a exponer cómo con una vivienda
Hello, my
passiva
name is
los
Alvaro
interiores son
Sancho,
mucho más
and
eficientes
today,
y
together with my
económicos.
colleague Andres,
Vamos a ver
we're
desde
going to explain
diferentes
how a
etapas
passive house
vamos a ver
building
cómo ha evolucionado la
will not just be
normativa
more
relacionada
efficient,
con los filtros
we'll also
y
show
cómo
how
se ha
we can
evolucionado
improve air quality in the
los
building.
interiores exteriores
During this
desde el punto de
presentation,
vista
we'll see how
de la
regulations and
relación que hay
standards in
entre
relation
unos
to
filtros
filters have
internos
evolved,
o unos filtros
how they've been
entornos y
unified,
unas
and the different interior and
características
exterior contaminants we can find, and the relationship between energy
actualmente
consumption and the
los
use of
filtros
better or
están
worse quality filters for the interiors of our homes.
tratamos el 90%
At
o incluso
present,
más
as I'm
de
sure many of you know,
de nuestros
and
hogares en
particularly
lugar de
given the
fuera.
current situation with
Y esto
COVID,
provoca
we
que
spend
una serie de
90% or
contaminantes
more of our time
denominados
at home,
externos
indoors, and in
debido al
closed
uso
spaces.
de la Organización
This
Mundial de la
means
Salud
that the
ha definido ya unos
indoor air
límites de
is often 8
contaminación
times more
relacionados
contaminated than outdoor air.
la Organización
As a
Mundial de la Salud
result, the
los define
WHO has
como
already defined a
riesgo
syndrome
crítico de
called sick
afecciones a la
building
salud
syndrome,
desarrolladas por los usuarios y originadas o agravadas por los
and it
contaminantes
defines it
del
as
propio edificio.
a situation in which occupants of a building experience one or more adverse health systems that seem
Debido a
to be
la
related to the time spent
normativa
indoors and also the
aplicada
quality of the air in the building.
nosotros en Passivhaus vamos a poder determinar las barreras a estos contaminantes. Una de ellas la
For all of
normativa
these
ISO, que es
reasons,
donde se va a centrar el grueso de nuestra exposición,
and with a pH certified building, we can establish barriers to contaminants. One way is using a filter, continuous ventilation, which will prevent the entry of all exterior
A
contaminants.
continuación, mi compañero Andrés nos va a
Continuous
exponer cómo una
ventilation will
esta
also
normativa.
allow us to eliminate contaminants which may be found in the property. My colleague Andres is now going to explain how these standards and regulations have evolved in this sense. Thank you, Alvaro. The ISO 16890 standard establishes the technical requirements and specifications and criteria for filters used in general ventilation based specifically on suspended particles, particulate matter, and as we'll see later, this has been defined as PM or ppm. PMs, particulate matter, are the most representative element of air contamination and may affect people just like any other contaminant. The standard arose from the need to harmonize globally the different standards that existed worldwide. Another reason for this new standard was to ensure that trials and tests were closer to reality. If we compare this with the previous European regulation, EN 779, for testing filters, well, in those cases, a test was performed with filters electrically loaded or charged, electrically charged filters to increase filter performance. So we're talking about laboratory values. The new ISO standard 16980 performs the same test but also includes a second test with filters without electrical charge, which would be used in the real life cycle. The result is then calculated as an average between both tests to obtain the corresponding license for the filter. Some of the filters that were previously on the market are currently non-compliant, therefore. The idea being to obtain and guarantee better air quality. And finally, the third reason was to focus the standard on particulate matter that affects human health. In this case, PM1, which corresponds to 1 micron particulate matter, is considered by the WHO as the most dangerous for human health. Although it's true that these changes in the way of testing and classifying filters means that there's no exact correspondence between the previous standard and the new one, we can establish certain similarities, as are shown in the table. The new classification by particle size, PM1, 2.5, 10 and thick, with increases of 5%. This increases the range and provides more specific details of the reality in this case. I'd now like to hand back to my colleague Alvaro, who's going to talk to us about outdoor and indoor contaminants As Andres mentioned, we're going to look at these contaminants for which we need to apply barriers to avoid them entering our buildings, our properties. One of the most important is ozone. As you can imagine, stratospheric ozone, ozone in the stratosphere, is necessary for life to prevent the passage of solar radiation. But tropospheric ozone is harmful for health. This ozone is created in hot climates, and solar radiation triggers a chemical reaction with certain contaminants, for example, from exhaust pipes or from factories. Also, there can be different contaminants together depending on their size, such as microparticles or particulate matter, as Andres mentioned before. These contaminants come from burning of fossil fuels, from automobiles, factories, energy plants, and even forest fires. And as we'll see later, depending on their size, they can be more or less dangerous. In this slide, we can see a series of important points. The icons with each of the aspects that would affect human health. In dark, that would be contaminants that would correspond to microparticulates, which will affect lungs and have a cardiovascular impact, depending on their size, so they can reach different parts of our body. Ozone is another contaminant. It's less harmful, but it can cause pulmonary disorder. And then within buildings, within homes, the number of contaminants increases. VOCs, volatile organic compounds, and CO2 can also increase or decrease depending on the quality of ventilation. So within our homes, we can also find particulate matter, which will affect us in the same way as we saw before, such as tobacco, ash, which can create asthma and different cardiovascular diseases. But we will also have to take into account contaminants such as CO2, which can be generated by human activity. Contaminants such as volatile organic compounds from perfumes, and which will normally have an action or have an effect in our homes. And if there's poor ventilation, their impacts can be worsened or aggravated, and they can also be related to different allergies and damp. And under Spanish regulation, something that's also being considered is radon. Radon is introduced or enters our homes through flooring or through the actual construction materials used. It's a contaminant that has to be considered because it's been shown that it's the second cause of lung cancer after tobacco. As mentioned previously, depending on the size of the particles, depending on the particle size of the matter in each case, it can affect us in one way or another. 100 microparticles can be retained in nasal fossa. They may not be harmful, but as from 10 micra, they can enter the throat. 2.5 micra, the lungs, and 1 micra, they can reach the blood. Therefore, depending on their size, they will affect us in one way or another, and their impacts can be worse. My colleague Andres is now going to explain. Thank you, Alvaro. When addressing indoor air quality in homes with low energy consumption, design is essential together with the implementation of innovative systems to guarantee continuous flow and also air purification and heat recovery as required in the Passivhaus standard. For the preparation of this article, we use the technical information for advanced ventilation and purification system designed by Aldes, specifically the Inspire Air Home model, as you can see in the picture, which consists of ventilators with electronic switching equipment, low consumption, parallel panel heat recovery system, and also a compartment for air filtering. For this article, we studied the increase in energy consumption of the equipment. This is an Inspire Air model, and under Passivhaus, we can see the level required by Passivhaus. The ISO standard requires an FP1 filter at 50%. That's at particle level. We also studied electricity consumption of the same equipment, but with an EPM1 filter with 80% retention, in other words, 25% more capacity to retain 1 micron particles, represented by the purple curve in the graph. It's to be expected that higher filtration or greater filtration will lead to an increase in load loss or charge loss, because filters present greater loss, and as a result this would increase consumption. That would be the normal behavior of the curve, which would rise. But in the case of a 90-meter squared property occupied by 4 people, and there would be areas with humidity in the kitchen, bathroom and toilet, and with 0.44 renewals per hour, the result is very interesting in this scenario, because there's an increase in air quality, which was the aim of this study, but it was low. In the following table, we present an example for this home, taking into account an energy price of 0.14 kilowatts. The increase in consumption was 7.69%. Furthermore, this would represent an annual cost increase of 4 euros in energy, without taking into account recovery. If we were to add the cost of a new filter for impulsion and in extraction, for maintenance of an annual filter change, the percentage increase would be 9.36%, which would be below 14 euros per year, giving superior air quality. Conclusions. We confirm the correlation and difference between old filter standards and the new international standard. New categories have been created to classify filter types according to particle size. We refer to particles, but names have been assigned. So we have particles of 1 micron, virus, nanoparticles and exhaust gas, 2.5 microparticles, which would be fungi and spores, 10 microparticles such as pollen and desert dust, and finally thick particles like sand. So 10 micro would represent the thickness of a single hair, and the standard refers to particles of 1 micrometer. So, as a final conclusion, the WHO explains the main problems associated with poor air quality in indoor spaces, closed spaces where we spend most time, and particularly important in the current context. It's true that the sector has to be more aware of indoor air quality, and that is the case, and adapt nomenclature to new standards. It's also possible to improve air quality indoors using higher category filters than those required in the Passivhaus standard. And it's also been verified that the economic cost of using higher capacity filters doesn't represent a significant increase in overall costs. For my part, and on behalf of Eduardo Alvaro, I would like to thank you for your attention, and more information is available on the article. Thank you for your attention. Thank you very much also on my part, and I hope the presentation's been interesting.